Alright, this is just a quick review on the temperature time graphs, the temperature versus energy graph. And so here is just a sample for water, and I wanted to remind you that anytime that you have a diagonal portion on here, you're dealing with one state of matter that's present. In this case, we have a solid because it's below 0 degrees. This is a liquid because it's in between 0 degrees and 100. And over here, we have a gas because it's above 100 degrees. So whenever there's a diagonal, we just have one state of matter present. Now, with that being said, if there is ever a diagonal, I'll come over here and say diagonal, and we use the equation Q is equal to mc delta T. So on your worksheet, anytime that you're dealing with something that's just strictly a temperature change, it follows the equation Q equals mc delta T. There's some important information about here, like for instance, C is a constant. That C right there is a constant, and for liquid water, it is 4.18 joules over grams times Celsius degrees. And then for a solid, it's a different value. It's a smaller value. It's 2.1 joules over grams times Celsius degrees. And so all that being said, that's really important because this basically says that the solid is easier to warm up than a liquid is, because the liquid, according to this, it requires more energy per gram and per Celsius degree raised. So that's the diagonal portion. Always use Q equals mc delta T. If you're talking about a flat portion, that's where you're dealing with a phase transition. So you're going from a solid to liquid, which we call melting, and then you have liquid to gas, which we call evaporation. Now, if they're on a flat portion, they do not follow this equation. They follow a different equation. Both of them, I'll come up here and say flat. Both of them follow basically this. Q is equal to mH. Now, the H is different depending on whether it's here or here. Mass stays the same, but H is different. And so down here, you're talking about what's called the heat of fusion. And up here, you're talking about the heat of vaporization. The heat of vaporization is 2260 joules over grams. And I don't have it in front of me, but I'm pretty sure the heat of fusion is 334 joules over grams. I'm not 100% sure if I remember that correctly though. That's significant because it tells us basically that in order to vaporize something, it requires a lot more energy than it does simply to melt it. And so whenever I'm dealing with a diagonal portion, I want to use this equation, and depending on whether I'm talking about a liquid or a solid, then that C will change. If I'm ever dealing with a flat portion, I'm either going to use this number or this number, depending on whether I'm melting or freezing, or I'm evaporating or condensing.